if you like. Good morning. Good morning. Good morning. Good morning. Good morning. We are still good morning. Yeah, we are still good morning. Good morning. Come in, we are open. Good morning.
Good morning.
Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Wonderful good morning. Most wonderful good morning.
Best.
Yes, bestest. Good morning. So where's the rest? Good Lord, there's nobody here. Have you just had a lecture somewhere? No. Oh, or is it just simply Thursday lunchtime? Good morning, good morning, good morning. Most wonderful good morning, good morning. Good morning. Good morning. Good afternoon. Oh, good after morning.
I mean, good morning.
Either. Good after morning. Most wonderful good after morning. Most wonderful good after morning.
Hello.
Good after morning. Good after morning. Good after morning.
The same.
Good after morning. 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 Most wonderful good after morning. Good after morning. Good after morning. Good after morning. Good after morning.
So I have no idea.
Good after morning.
Good after morning.
I'm looking for a willing victim. Are you a willing victim?
Not quite.
Not quite. You don't know what you miss. Would you be happy to play with me a little bit?
Yeah, sure.
Good. What's your name?
Bolu.
Bolu.
Yeah.
Okay. Now here's the thing. I will ask students to pick a number.
Okay.
That doesn't apply to you. Okay? Your number is 160. Can you write that down?
Yep.
Fantastic. Thank you. You already stoked for some more statistics?
Oh, yeah, always.
You look so sincere.
I am. You know what? I even didn't go out and stuff just so I could be here.
You didn't go to Wednesday.
No. Just so I wouldn't miss your lecture. That's the level of
I feel,
dedication.
I feel, I feel, I feel totally humbled and honored.
You should.
Yes, because I know what it means to you.
Yeah.
Is it really that good, Wednesday?
No, it's awful. You just have to be
Do you
really
have
drunk.
do you have sort of? I mean, you don't have to answer that, but do you have some kind of masochistic tendencies?
No.
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 So you don't like to be
No, you just
chained
have
to a radiator.
You just have to get really drunk for it.
Everything's good if you're really drunk.
Sorry?
Hello. Everything's good if you're really drunk.
You just have to be really drunk.
I go to clubs when I'm really drunk. I hate people.
Yeah.
Like,
Okay, let me digest that. Let me mentally digest that. You hate people, but when you are
give me
drunk,
enough
you
vodka,
go.
I'll go to the clubs. I'll talk to anyone as well. Like, alcohol's like.
You need
the
to
only
come to
reason-
Wednesday.
You should do it.
Come on, come with me next
Sorry,
Wednesday.
folks, I'm too old for
Next
that.
Wednesday.
Look,
Never too old.
my bedtime is usually around 9 o'clock.
It's alright, you can push the boat out for one night.
Yeah. Like
I'll buy
I
you a
said,
pint.
anything.
I will consider it.
I'll buy you a pint.
No, thank you. It's very kind of you, but no. No. Okay, shall we make a start? Despite these very tempting offers. A most wonderful good after morning, everybody. Please note, as per usual, attendance, Moodle, you know what you have to do. Wherever in the world you are, right, just click the I am present button. Also, can I remind folks, please, that there is still quiz 1 for BI 308 is open until Sunday, 5 o'clock, I think. You can do the quiz as often as you like, and only the best mark will count for this module in this quiz. So please do that. Probably tomorrow afternoon, I will open quiz 2, and it will be in the weekly email that you get the link to it, and also, you know, when the deadline is and how much this quiz counts. Okay? So watch out for email. And by the way, I will do a similar thing for those of you who are doing BI 301 for the enzymes module. I will also send you, as per usual, an email, and I will give you the link to the first quiz. Okay, so before we get started today, I want you to do something for me. I want you to choose a number between 70 and 130, please. Yeah? It can be a whole number, it can be decimals. It can be as many decimals as you like. Anything between 70 and 130. And please write that number down, because otherwise you will forget. We need this number later. Okay? So, just a quick recap of what we have done in the last lecture. And I gave you an introduction to this absolutely brilliant distribution, the normal distribution. And we said a normal distribution, also known as a bell curve, many observations in nature follow this bell curve. The normal distribution is a symmetrical distribution. It has a special population mean, and in this case this mean is the same as the median, and it's also the same as the mode. And if that was our population, it also has a standard deviation. And the characteristic of that, as I said, it is symmetrical. The peak is the mean of this thing. And the shape of that curve is defined by the fact that if we go one standard deviation above or below the mean, we have 68% of our data in this range. And if we go 2 standard deviations above and below the mean, so that would be the green range, we have, what was it? 95%. Thank you, Katie. 95% of the data are in this range. Probably not exactly how I drew it, but you know, let's assume that it is correct. Yeah, that was something that we discussed last week. So, for example, the height of, let's say, students would probably be very close to a normal distribution. We also said we can kind of develop or calculate what is commonly known as the Z-score. As the Z-score for an observation. And we said we just take the value that we are interested in. And this value, we usually can give it a name. This is what you will frequently encounter when you watch YouTube videos, Khan Academy or something like that. This is called a random variable. Random variable just simply means that's the thing that we are interested in. It is sort of almost random, and it's a variable because we can basically pick whatever we want. And it's usually abbreviated with a large X. It's just simply a random variable. It's just that the thing has a name, nothing further exciting. And the Z-score is defined as this random variable minus the mean divided by the standard deviation. It basically tells us how many standard deviations this random variable x is away from the mean. That's all what it says, this Z-score. Yeah? That makes sense? So that's the Z-score. We also said we can go further than that, and we can actually not just look at one observation like our random variable, but we can, for example, take a sample, the height of several. And then we would have a different distribution. We would not have a normal distribution as it is like that. We would have a different distribution. Again, a normal distribution, but we would have a sampling distribution. Because we have a sample. And in this case, again, we would have our normal distribution. If we have a sample, we might have a sample mean, and we might have a sample standard deviation. That's from our sample. It's not the original, it's just a sample. And if we take this sample, we have our, again, normal distribution. And this time, our sample mean is the mean of that. And we have, again, standard deviations, but in this case, it would be the standard deviation would be the standard deviation for our sample, which is denoted like this, sigma x bar. That indicates that it's the standard deviation for the sample. And it turns out that there is a nice correlation between the standard deviation of the sample and the original standard deviation, in that this standard deviation of the sample is the standard deviation divided by the square root of the sample size. I think that is where we stopped last week. What I want to do today is I would like to put a little bit of flesh on the bone. So, for example, a very typical thing that people believe shows a normal distribution is intelligence. You probably know people do all sorts of weird and wonderful intelligence tests, scores of God knows what. You have these questions, or also non-verbal things. You probably have done that at school, haven't you? Sort of, how high do you score in this test? How high do you score in non-verbal reasoning, verbal? Have you done that? No? You have done it? Yeah? So some people do that. In my view, these tests are total and utter, because they don't tell you anything. And you can train it, how to answer these questions. But then one would argue, can you train intelligence? I have my doubts. Anyway, let's assume intelligence has a normal distribution. And you will find there are some data in the literature for that. And it turns out, and I don't make that up, right? Don't make that up, that for IQ, the population mean for the UK, the population mean for the UK is 100 score, 100.0, and the population standard deviation is 15. I'm not going to ask you that in an exam. It's just numbers. So, these are the parameters. Now, I want you now to do a little intelligence test and see how high you score. And to save you from embarrassment, you have already got a score. Have you got a score?
No, because well, if it's talking about IQ, it's not, I could barely put my shoes on. So I picked 90, so that's like close to mental.
Okay, you've got a score.
72.
Yeah, mate, you can't even like make no breakfast.
You have got a score because I've asked you to pick a number between 70 and 130. So, quick question. Who has got an IQ, a pretend IQ, higher than 100? Hands up. Oh, that's interesting. Who has got an IQ lower than 100? Hands up. That's interesting. But if you probably did the numbers, you would see that, well, actually, it's probably not too different from each other if we do frequency counts. And I tell you in one of the following lectures how you can actually do this. Have students a sort of preference for something like that? Now you've got your IQ score, right? Now I want you to calculate the z-score from this equation here. X bar, this random variable x, that's your score that you have given yourself. Mu is 100 and sigma is 15. What's your z-score? Is it positive or is it negative? Olu, what's your z-score? Good man. So, you've got your z-score? How many people are positive? How many people are negative? Okay. Wonderful. Now, here's the thing. I am actually recruiting people for a very special program. And I want only the most intelligent people on this program. I want only the top 10% of people on this program. This is what frequently happens when you do a selection process. If you want to apply to medical school, for example, you have to do a test, and then they say, we want only the 10% of the top people. I want only the 10% of the most intelligent people. So, how am I going to do that? How do I find that? First of all, I can use my normal distribution. And I can say, just to visualize the problem, what am I looking for? So here's my 100. And what I am looking for is people who are in that range. So I am looking for somebody who is really intelligent in that range with the number, right? We need to find what this number is. Where is this number here? At what intelligence do we deal with? Well, let's turn that around. We can also say, for example, what was your score? 90.5. Oh, that's an interesting one. 90.5. So, what's your name?
Kieran.
Kieran. So, where is Kieran located in that? Is he, very clearly, he is below average. But in terms of, you know, how many people are as intelligent as Kieran or more intelligent? That's one of the other questions that we can ask. So you would probably be somewhere, let's say here. That's K. Kieran is situated here, right? Let's try and figure out how many people are more intelligent, or at least as intelligent as Kieran, or more intelligent as Kieran. Let's see how many, what is the percentage? Who has a score higher than 90.5? Hands up. Okay. Who has a score lower than 90.5? Ah, less people. That's quite interesting. That gives us already an idea. So what we are looking for is, we are looking for the percentage of people we are looking actually for the percentage of people who are in this range here. Yeah? That tells us how many people are at least as intelligent as Kieran. How many people here in this room are exactly 90.5? Hands up. Oh, that's interesting, isn't it? You are unique. The normal distribution actually is a continuous distribution, and it's very unlikely with this continuous distribution that you find somebody who is exactly one of these numbers. Is anyone here 90.2? 98.7? No. So that's why when we deal with a continuous distribution, we say we are looking for not just a sharp number, we are looking for a range of numbers. Yeah? So in this case, we say we want to see how many people are at least as intelligent as Kieran. Can we already say, can we already make a sort of a guesstimate? Is it more than 50% or less than 50%? More than 50%. Why?
50% is at the mean of 100, and
So-
more than the mean, so
You're absolutely right. So 50% would be this region here. Yeah? So at least 50% are more intelligent than Kieran. Plus we've got this bit here. Well, we need to find out what this bit is. How can we do that? Well, the clue is actually in yesterday's group chat. And Ben kindly provided some very interesting insights. Thanks, Ben. Because Ben said Klapper does everything with Excel. And maybe he can get Boris Johnson out of Downing Street or disarm the North Korean nuclear program or things like that. No, Klapper can't do that, right? But Klapper can show you how we can actually get to find out how many people are at least as intelligent as Kieran. How do we do that? Well, Excel is brilliant because it has a special function for that. The function in Excel, as you all know, starts with an equal sign. We are dealing with a normal distribution. And the command is norm.dist parentheses open. It is looking for our random variable. It is looking for the mean of the distribution. It is looking for the standard deviation of the population. And it asks whether it should take the cumulative result and cumulative just simply means, do you want me, bless you, do you want me just to take one single value? And of course we said that's nonsense. Or do you want me to take the area under the curve? And that is what we want. And here, cumulative, we would type in true. Or if you are too lazy like me and don't want to type true, you just simply put a 1 in. Right? Let's see what happens. Okay, so equals norm dist, it already turns up. So it asks us for the variable that was 90.5. 90.5. It asks us for the mean, that was 100. It asks us for the standard deviation, that was 15. And for cumulative, we just simply say 1. And it comes up with a weird number. It comes up with 0.2632. Let's write that down. 0.2. So if we do that, we get 0.2632, or that's the same as 26.3%. surely that can't be right, because we said it must be higher than 50, right? Actually, what this norm does, it does exactly the opposite to what we want. It doesn't calculate the red bit. Oh, wow. It doesn't calculate the red bit. It actually don't know whether you can see that. Yeah, it actually calculates the yellow bit. So norm disk calculates everything that's smaller. But that's not a big problem, is it? Because we know that the whole thing, the area under the entire curve is, what is that? 100% or 1. Yeah? So what we can do is we just simply take 1 minus the yellow bit. And we get 1 minus 0.23263, and that would be 0.737. Is that right? Have I done it right? Yeah, I think so. So that would be 73.7%. Or in other words, 73.7% are, in this case, more intelligent than Kieran. Of course, we don't believe that. No. Yeah? Does that make sense to you? Okay, we have another one. Shall we quickly do another person just to establish it? Bolu, what was your score?
160.
160. Whoa. Is he intelligent? Let's see how many of you are above 160? 160 or above? Of course, nobody is, because I told you only to pick a number between 170 and 130. I gave Bolu the 160, so it was not that he was, naughty. I told him to go for 160 because we need that later. So we can check how many people are actually more intelligent, or at least as intelligent as Bolu. Let's see. Have you done it? You're trying to do that? Yep. So all we need to do is we need to change just one number here. So we change that to 160. But we can already intuitively say 160 is, wow, right at the end of the spectrum. So we get a number of 99.9968. Or in other words, if we have somebody with an IQ of 160, that would mean we have 1 minus 99.998% are below that. Or we can say he is certainly in the top 1%, in the top 10%, yeah, with his IQ. So with this norm dist thing, we can calculate the percentage of people who have an IQ or higher than that. Yeah? Or who have height higher than that. For example, I told you last week that we could also go for, height. Oscar said he was 188 centimeters. Do I remember that right?
Yep.
Yeah. And 180 centimeters is the mean. And we can simply check how many people are actually as tall or taller than Oscar. Yeah? With this function. Now, as I said, I want to recruit people for my super intelligent program. I now know what I want. I want people who are in at least top 10% of the IQ. Yeah? Now I have to do it sort of the other way around. I don't have a number that I could put in, but I have a percentage. So, as I said, I'm looking for the top 10% of people. So I'm looking for that. So I'm basically looking at an IQ here, where people then are as intelligent or more. And again, there is a brilliant function for that in Excel, and Excel does everything for you. Here the function is norm dot. We are not doing the distribution, we're doing the inverse of the distribution. Norm inv, which stands for inverse. We now need to have the percentage, but again we need to be careful with that. Excel will do the percentage that are lower. So it would be this bit here. So we are looking not for the 10% top, but we are looking for the 90% that are below. So this would be 0.9. But otherwise, it's exactly the same. I don't think we need to worry about the cumulative. So let's see what we get with that. We go for equals. Norm dot inv. The probability, we said we want 90%, so 0.9. Our mean is 100, and the standard deviation is 15. And here we are presented with the value. We need to have an IQ of at least 119.2. How many people in here have chosen a number higher than 119.2? Hands up. Hey, welcome on board. You have been selected for the super intelligent program. You see how it works? Now, if we want to do it this way, we need the mean and we need the standard deviation. But we can make life a little bit easier. We can also do that with a z-score. And if we have a z-score instead of the random variable, Bolu, what was your z-score earlier? 4. Excellent. So we can try and see what is the z-score. Or what is the probability, how many people have a z-score below 4? And here we have another function. You don't have to learn anything really new. It is norm.sdist. And here we just, it asks us for the z-score, that was 4. And cumulative 1. And look at that. We get the same number, 0.999968. So we can do it either z-score or we can do it with the random variable. So that was for an individual. What about, oh yes, let's do that. Let's do that. What about I take a sample? How can I handle a sample? Now, let's see. 90.5. What was yours?
72.
Oh dear. 90.5. 72. 100? 127.3. I love that. Oops. 100. I can't even do that properly. 0.3.
88.
88. You're sort of borderline, huh? But not as bad as Alex.
No.
Okay. Okay, let's just quickly calculate what is the average here. Equals average. The average is 94.45. Right? Now, what I can do now is I can say, okay, instead of an individual, I have now taken a sample of these 4 hopefuls. Let's see where this group of people stands in terms of, intelligence. Now, what I need to bear in mind now is that it's no longer individuals. I have taken a sample. And remember, we have a sampling distribution now, because it's a sample. Bless you. And the sampling distribution has a different standard deviation. So we basically have to deal, when we input these data, with a different standard deviation. we still have 100 for our sample mean. Sorry, we have 100 for our population mean. Shouldn't write it like that. But our standard deviation has changed. But we can easily calculate that. We know that the original standard deviation was 15, and the standard deviation for our sampling distribution is the original standard deviation divided by square root of n, and that was 4. I picked 4 individuals. So we had 15. 15 divided by square root 4 gives us 7.5. Yeah? Make sense? So what did we have? Let's see where these 4 hopefuls, where this group of hopefuls lies. How many other groups of 4 there are, and where this group of 4 actually is located in terms of IQ. How many other groups of 4 are as intelligent as they are? So what we do is equals norm dot dist. Here it asks us for the average. That was, what was it? 94.45. Thank you. The mean, and this is the population mean, is 100. The standard deviation, now it is the standard deviation of the sample distribution. So it's not 15, it's 7.5. And we still want the cumulative 1. So we have shy of 23%. What does that mean? Well, if we think about it, 94.45 is around probably here. Let's do a different color. And what the program calculated is everything here. And that was 23%. So 23% of, and here comes the tricky bit, 23% of all quadruple groups, not of the individuals, of the quadruple groups, are below in their intelligence than those. Or in other words, 77%, not of the individuals, but of the quadruple groups, are more intelligent, or at least the same or more intelligent than this group. Does that make sense? Yeah? So you see the difference between the individual and the sample lies in the fact that when we have the sample, we need to adjust our sample standard deviation. Yeah? And that's something that's absolutely crucial, and we need to bear that in mind. Are you happy with that? You do a little bit of practice, and I'll see if I can dig out a few practice questions for that. Yeah. Otherwise, I wish you a lovely weekend. Please don't forget to do your quizzes if you haven't done so. You can also see on the website whether you have done it. And before I forget, wait. Before I forget, you are asked to click on your login, right? Please make sure it's your responsibility that you click on the right one. Yeah? If you click on the wrong one, then it will account for the other person. I know that at least one person has clicked the wrong one, because I haven't done the test and I still show up on it. Right? Have a good weekend.